Good morning, students. So after completing the local maxima and local minima, so today we have to start the next one, which one is the second derivative test. Actually, in first derivative test, we discuss about absolute maxima and absolute minima, as well as local maxima and local minima. These two are under first derivative test. So now today here we discuss the second derivative test. So for the second derivative test, we directly take an example. With the help of this example, easily we can know or we can solve the second derivative test questions. So actually, how can we identify the second derivative test question? If you see the example here, the example is directly given. Find the maximum and minimum values of the function of given by fx equal to x cube minus twice x plus 3. Now in this question, if you see here, we have to find out the maximum minimum. If here the closed interval given to us, then we know we have to solve with the help of first derivative. Is not it? Absolute maximum and absolute minimum method we have to apply. But here the closed interval is not mentioned. So from that, in this way, we can identify this. In this question especially, we have to apply the second derivative test. Is it clear? And one more thing here, in second derivative test, what you have to do, generally the second derivative test we use for trigonometry function or algebraic function. So now here we have to discuss the working rule. How can we solve? What is the procedure method here to solve second derivative test here in this question especially? This type of questions. So now here in this question, if you see, the question is given maximum and minimum values we have to find out, and the function is given fx equal to x cube minus twice x plus 3. This one is the function here. This one is the function, and here we have to find out the maximum and minimum value. And for this, first of all, what you have to do, we have to consider the function fx equal to x cube minus twice x plus 3, and then we have to differentiate. The first step is here, what you have to do, we have to differentiate this one with respect to x, because here the function is given x. So if we differentiate this one with respect to x, so easily we can write here f dash of x equal to what you have to write, x cube. If we differentiate x cube, then it is 3x square, and here if you differentiate this 3x, then it is simply 3. So here we write 3x square minus 3. Is it clear? Okay. Now f dash of x equal to 3x square minus 3 we get. So now f dash of x equals to 0. F dash of x equals to 0. Second step is what? F dash of x equals to 0 we have to write, and f dash of x equal to 0. Why we write f dash of x equal to 0? Because whether it is maximum or minimum we don't know. That's not it. So that's why maximum greater than 0, minimum less than 0. In first derivative we know. So here we don't know whether it is maximum or minimum, so that's why we write f dash of x equals to 0. So f dash of x equals to 0 we write here, and in place of f dash of x we put this function 3x square minus 3. So if we put 3x square minus 3 here, and then 3 common, then 3x square minus 1 equals to 0, and simply we write here x square minus 1 equal to 0, because all of you know here, because 3 is not equal to 0, so that means only the possibility is here x square minus 1 equals to 0. So now here after that, it is of the form a square minus b square, isn't it? So a square minus b square, here we have to apply x plus 1 into x minus 1 equals to 0. And then after that, from here, if you find out the value of x, then the x values are we get, two values are we get here. One is x equal to minus 1 and x equal to 1. You see here. Is it clear? So up to this, in absolute maxima, absolute minimum, local maxima, local minimum, and now here in second derivative test, the same procedure we have to apply up to finding the value of x, and these two values are known as critical point or stationary point. Is it clear? Okay, now after critical points, the procedure will be little bit changed. So that means from here what we know, the working rule for the up to critical points for all these three methods are same up to this. Now here the procedure will be, the working rule will be little bit changed here. So after that, what you have to do, after finding the critical points, so after finding the critical points, whatever we differentiate at first, f dash of x equal to how much we get here, 3x square. F dash of x equal to 3x square minus 3 we get here. You see here, this function again we have to differentiate. This one again we have to differentiate in second derivative test. After critical point, this one is the first step. What you have to do? We have to differentiate again. So if we differentiate this one again, f dash of x equal to this one, if we differentiate, then second derivative f double dash of x equal to what we get here, 6x, because 3 constant term x square means twice x, 3 to the 6, a constant term 0, so simply here we get 6x. Is it clear? All of you understood? After critical point we have to differentiate the function again, so here we get second derivative. Second derivative value is we get here 6x, and after finding the second derivative, now the critical point we have to put one by one. We have to verify, actually we have to verify at which point we get maxima and at which point we get minima, and for this what you have to do, we have to put the critical points one by one, and in this case what you have to do, so one by one we have to verify. And now here when we put at first x equal to -1, the first critical point is -1, so when we put x equal to -1, so x equal to -1, when we put in the second derivative, then here in place of -1 we get a negative value. This -6 is not so important. Here we have to identify whether the value is negative or positive. This one is more important because here we have to find out the maxima, not maximum value. We have to find out the maxima or minima point. So that's why here whether it is positive or negative we have to just verify. This one is actually the verification part. So when we put x equal to -1, so in place of x if we put -1, then we get -6, that means negative value. So negative value means less than 0. So f double dash of -1 when we put, then we get negative value, that means less than 0. So now here the procedure is totally changed from the first derivative. In first derivative when we get less than 0, then we get minimum, but in second derivative when we get less than 0, then we get maximum value. Understood? Then we get maximum value, totally opposite of the first derivative. And now similarly here if you see, when x equal to 1 we put, we get positive value. Positive value means greater than 0, that means greater than 0 means what? Minimum value. So what is the meaning of this maximum and minimum? So when we put x equal to -1, that means we get maximum value. That means our verification is here complete. That means from here easily we can say, when we put x equal to -1, when we put x equal to -1 on the given function, so given function is which one? The given function is, if you see the given function is this one, fx equal to x cube minus 3x plus 3. So when we put x equal to -1 on this given function, then we get maximum value. Is it clear? And when we put x equal to 1 on this given function, then we get minimum value. This one is the verification we have done here. Is it clear? This one is the verification. When we put x equal to -1, then we get maximum value, and this -1 where we have to put on the given function. And when we put x equal to 1, then we get minimum value, and where we have to put this one, we have to put this one on given function, then we get the minimum value. This one is just a verification. Here only we have done verification. This -6 or +6 is not the value. Is it clear? So now in this way, if we consider another example, let's take another example here. If you see, the example is like this. Why we have taken this example? Because if greater than f double dash of the critical point, whatever we put, if greater than 0 then minimum, if less than 0 then maximum. But if we get equal to 0, then what happens? So for that reason here we have to consider this example. So the question is here given, if you see, find the maximum and minimum values of the function f given by fx equals to x to the power 4. So now this one is the question here, and we have to differentiate this one. First step, all of you know, we have to differentiate, then we get 4x cube, and then f dash of x equal to 0 we have to put, and then from here the critical point we get x equal to 0. So the critical point is x equal to 0. Now we have to differentiate. After that, what is the procedure? We have to differentiate the function again. This, if we differentiate, then we get 12x squared. And now when we put, after differentiating, if we put the critical point, then x equal to 0, then f double dash of 0 equal to 0 we get. So if the value is equal to 0, it is neither positive nor negative. So that means we can't say maximum or minimum. So in this case, what you have to do? In this case, what you have to do? So in this case, we have to define set. For verification, we have to define set the function one more time. Is it clear? Because here when we put x equal to 0, f double dash of 0 equal to 0 we get, so that means it is neither maximum nor minimum. So in this case we have to define set the function one more time. So third derivative. So when we define set this one third time, so 12x square means we get 24x. Now again we have to put, after define set, again we put the critical point. And if we put the critical point here x equal to 0, if you see here, then again we get 0. If we get again 0, then again we have to define set. And this process is continuously going on when we get the value 0. So if you define set this one, then fourth derivative, then we get the answer is 24. So 24, and now again we put the critical point here x equal to 0. So when x equal to 0, we put f fourth derivative 0, then we get 24. That means this one is positive value greater than 0. Is it clear? Now here the important point is come here. If our value is finished at odd derivative, that means third derivative, fifth derivative, seventh derivative, these are known as odd derivative, then we have to write neither maximum nor minimum. Is it clear? Jodi amar third derivative, fifth derivative বা seventh derivative jodi amar differentiation to khatam hoy, tetia ami likhibo lagibo neither maximum nor minimum. Is it clear? So if the derivative is finished at even derivative, that means second, all of you know, fourth, sixth, eighth, like here you see fourth derivative, then here the second derivative procedure followed here. The second derivative, in case of second derivative, if greater than 0, then what we get? Minimum. So here in fourth derivative also we get minimum. If here less than 0, then maximum. বুজি পালা না সবে? ইভেন ডেরিভেটিভ হলে সেকেন্ড ডেরিভেটিভৰ যেটো প্ৰসিডিউৰ হেতুৱে ফলো হ'ব, আৰু যদি অড ডেরিভেটিভত ফিনিশড হয় তেতিয়া হলে নাইদাৰ ম্যাক্সিমাম নর মিনিমাম হ'ব আমাৰ আনসার. I think all of you understood these two example properly, and this one is the procedure of second derivative test. So it was the second derivative test or procedure. So এই দুটা কোয়েশ্চন তোমালকে ভালকে চাবা আৰু কিমান খিনি বুজি পাইছা মোক জনাবা. আৰু নেক্সট ক্লাছত ইয়াৰ ৰিলেটেড কিছুমান এক্সাম্পল অৰ কোয়েশ্চন আমি কৰিম. হ'ব? ঠিক আছে, থ্যাংক ইউ.